Hi, let's look at today's chapter Water for class 8 students. What are the different types of water? What is the chemical composition of water? What happens when water combines with metals? What happens when water combines with non-metals? What happens when water combines with metallic oxide and non-metallic oxide? We will look at all these aspects in this class. You all know water is the most abundant yet most important compound in this world. Why most important? I'll give you a clue. Do you think all the water available around us is fit for drinking? No, right? Yes. And water is the major constituent for all the living beings. Plants contain water. Human body contains about 65% of water. Neither plants nor animals can survive without water. From when we know water is the most important compound for us? It's immemorial. That means we don't even know from when our ancestors started calling water as holy water, Abi Zamzam, Ganga Jala, and giving respect to it. Which shows water is the precious commodity. Water has always been the driving force of every civilization and used it for different purposes like agriculture, drinking, washing, and other industrial purpose. In Ayurveda, water has been used for treating different common health issues, which is called hydrotherapy. Now we look at what is water made of. What exactly is water made of? What is the chemical composition of water? Water is made up of two elements, hydrogen, oxygen. One molecule of water contains two atoms of hydrogen and one atom of oxygen, which are chemically combined to form water molecule. Here is the chemical composition of water. Let me ask you one question. Do you drink water available anywhere around you? No, you don't, because the water available anywhere around you is not yet fit for drinking. That is why you need to purify your water before you drink. There are many ways to purify water which are traditionally inherited and we even now use at home, like boiling, adding tulsi leaves to the water, adding camphor to the water, adding red hot iron balls to the water, exposing it to sunlight. But how do you purify this water? How do you remove color, odor, suspended matters and microorganisms which are there in this water and which can even cause deadly diseases? We have different methods to remove all the above impurities I have just mentioned, like stages of coagulation, which is also called as sedimentation, which can be done by using alum, filtration, decolorization, deodorization, and sterilization. Even in the latest filters, ceramic filter candles are used. Do you even know why they are used? Here is why. Ceramic filter candles removes almost 99% of unwanted bacteria which can even cause diseases to human body from water. Water is a good fire extinguisher. Yes, but I would suggest you please think before you use water for extinguishing fire. because it can be a dangerous decision if the cause of the fire is electricity. Do you know hydrogen is a combustible substance and oxygen supports combustion, but water neither is a combustible substance nor a supporter for combustion. Why is it so? Let me explain you why hydrogen loses its combustible substance property and why oxygen doesn't support when it combines to form water molecule. The individual property of hydrogen and the individual property of oxygen are lost due to the change in the number of electrons when they combine to form a water molecule. If you look at the water molecule electrons, the number of electrons in the outer ring is changed to number 2. Now we will look at chemical property of water. We all know chemical formula for water is H2O. First thing, water is called universal solvent. Why? Because water dissolves almost everything you put in it and get dissolved. There are only few substances which don't get dissolved in water. Let me tell you a thing. Take a glass of water and add a pinch of salt. It will be a salty water. What happens in sea? Why the water in sea is salty? How did salt get mixed inside seawater? Let me explain you. The answer is simple. The salt in the seawater are due to the rocks on the land. Let me explain how. The main source of water to the sea is rainwater and rivers. The rainwater and the river water erodes the rocks on the land, which contains minerals and other salts, and finally reaches to the sea. And when evaporation happens, the salt remains and water gets evaporated. This is happening from very long time, and the salt content in the water is high. That is why the sea water is very salty. Now let us see the action of water on metals. In your daily life, you will be drinking water in metal cups like steel cup, copper cups, and we boil water in metal containers. Does the water react with the containers? No, right? Because the metals like copper, aluminium and tin shows no reaction with water. That is the reason why they are used with other alloys to make kitchenware items and other utensils. We do have other soft metals like sodium and potassium. They does react with water, forming potassium hydroxide and sodium hydroxide, liberating hydrogen gas. This is the reason why potassium and sodium are stored in kerosene. Otherwise, even the air moisture can cause chemical reaction forming potassium hydroxide and sodium hydroxide. If you have an iron chair or iron table or any iron rod at home and exposed to air, you might be seeing a red texture on those substances. Why do you see those things? It's called rust. How do you prevent the rust? Let me give you a hint. I'll paint the chair to prevent the rust. What are the other things you do to prevent the rust? Please comment below. The forming of a red texture on these iron chairs happens because the water content in the air or the water itself gets chemically reacted with the iron, forming hydrated oxide of iron. Here are the other metals which reacts with water. Calcium, magnesium. Calcium reacts with water forming calcium hydroxide plus hydrogen gas liberated. Magnesium reacts with water forming magnesium hydroxide plus liberating hydrogen gas. When steam is passed over red hot metals like iron, zinc and magnesium, respective oxides are formed with hydrogen gas. And here are the chemical reactions happening with the chemical formula. Zinc reacts with steam forming zinc oxide plus hydrogen gas. Iron reacts with steam forming magnetic iron oxide plus hydrogen gas. Magnesium reacts with steam forming magnesium oxide plus hydrogen gas. Okay. Now let us see the action of water on nonmetals. When steam is passed over carbon, which is nonmetal, carbon monoxide is formed with hydrogen gas liberated. Here is the chemical reaction. Carbon reacting with steam forming carbon monoxide plus hydrogen gas liberated. The mixture of carbon monoxide and hydrogen in 1:2 ratio is called water gas. Water gas is used as industrial fuel and also in the manufacture of hydrogen in Bosch process. When steam is passed over silicon, silicon dioxide plus hydrogen gas is formed. Silicon plus steam forming silicon dioxide plus hydrogen gas liberated. Now we will see what happens when water reacts with oxides, metallic oxides, non-metallic oxides. Generally, when non-metallic oxides reacts with water form acid, and when metallic oxide reacts with water forming base. Carbon dioxide reacts with water forming carbonic acid. Carbonic acid is the one which is present in your soft drinks. We also have heard about acid rain. How exactly water turns into acid rain? We will look at it. We have several factories around us which exhaust carbon dioxide, nitrogen dioxide, sulfur dioxide to air, which eventually get combined with rainwater forming acid rain. Those are basically non-metallic oxides which combines with water forming acids. When metallic oxide reacts with water, it forms respective hydroxides. We already know metallic oxides are acid, non-metallic oxides are base. By the way, have you eaten jaggery? Obviously. If you keep jaggery in your hand for longer duration, you will feel moist. Why? What does it mean? It means jaggery is tending towards becoming water. Like jaggery, there are other substances which also shows the same behavior when exposed to air. They are magnesium chloride, sodium hydroxide, potassium hydroxide, anhydrous calcium chloride, calcium nitrate and ferric chloride. These are the substances which absorb moisture in air, like jaggery. The substances like jaggery, which are water soluble substances when exposed to atmosphere at ordinary temperature. They absorb moisture from the air and becomes moist and ultimately dissolves in the absorbed water. Such substances are called deliquescent substances, and the phenomena is called deliquescence. Deliquescence is more common in coastal areas. Why? Because in coastal areas the moisture in the air is high. The substances absorb more moisture than usually. So, the process of deliquescence is higher at the coastal areas. There are other substances which removes water from the surrounding air. This is exactly the opposite of what we discussed earlier, which are called deliquescents or drying agents. Concentrated sulfuric acid and calcium chloride monohydrate are the examples for this. Certain hydrates means the substances which has water in it when exposed to air loses water. Example, sodium sulfate. It loses water content in it to become powder when exposed to the atmosphere. The loss of water from hydrated compounds or the dehydration process on these compounds is called efflorescence. As you all know, washing soda is another example for efflorescent substance. We know water is a good solvent, and the common source of water is rainwater, groundwater, and rivers. It is obvious that some impurities deep inside the earth, on the land, and other places get dissolved with water very easily. Calcium and magnesium get dissolved with water very easily. The percentage of these salts in the water increases, the hardness of the water also increases. If you have observed washing clothes or washing utensils or even while taking bath, sometimes you observe high lather and sometimes you see a very less lather. Why did this happen? Have you ever imagined? It is because sometimes you will be using hard water and sometimes you will be using soft water. Generally, the water from the areas having limestones and other mineral rocks is hard. Calcium and magnesium bicarbonates, sulfates, and chlorides are the general cause of hardness in the water. The salts causing the hardness of water are water soluble. Calcium carbonate is insoluble in water. That is why it doesn't cause hardness in the water. On the other hand, soft water produces rich lather with soap. Why is hard water not used in industries? Let me give you an experiment. Take two containers, one with soft water, another one with hard water. Boil it for few minutes. Observe it. Soft water doesn't show any changes, but hard water, if you observe, there is a white substance formed on the surface of the container. The white powder like substance on the hard water container is the dissolved salts in the water, which has become insoluble salts on boiling. In industries, the salts get deposited on the surface of the boilers and it takes longer time to boil the water, as well as the salts deposited on the surface of the boiler will be the reason for the explosion. How do you remove the hardness of the water? If the water contains calcium and magnesium bicarbonates, it can be made soft by boiling. Calcium bicarbonate decomposes to form insoluble calcium carbonate with carbon dioxide. Another way is to add washing soda. The calcium and magnesium converts into insoluble carbonates and the sodium salts get dissolved with water without causing the hardness. but it is not fit for drinking because of excess of sodium salts. Is it possible to purify seawater for human potable water? Yes. Desalinization is the process where the seawater or saline water can be made pure water for human fit drinking, which is invented during Second World War, and the byproducts is your table salt. In the end of this chapter, I would request to save water and use water very wisely. We will meet again in the next class. Thank you.